Pipeline concurrency is a critical aspect of DevOps that involves running multiple pipeline stages or jobs simultaneously. This approach can significantly enhance the efficiency and speed of software delivery processes. By optimizing pipeline concurrency, organizations can achieve faster build and release cycles, better resource utilization, and reduced costs. This presentation will delve into the various strategies and best practices for optimizing pipeline concurrency, ensuring that your DevOps processes are both performant and cost-effective. Pipeline concurrency refers to the ability to execute multiple stages or jobs of a pipeline at the same time. This is particularly useful in complex DevOps environments where multiple tasks need to be performed simultaneously to speed up the overall process. Concurrency can be applied at different levels, including job, stage, and pipeline levels. Understanding how to manage and optimize concurrency is essential for improving the efficiency of your build and release pipelines. Optimizing pipeline concurrency offers several benefits. Firstly, it reduces the overall time required for builds and releases, enabling faster delivery of software updates. Secondly, it improves resource utilization by ensuring that available resources are used efficiently. Thirdly, it can lead to cost savings by minimizing idle time and reducing the need for additional infrastructure. Lastly, optimized concurrency enhances the reliability and consistency of the pipeline. As tasks are executed in parallel, reducing the risk of bottlenecks. While optimizing pipeline concurrency has many benefits, it also presents several challenges. One of the primary challenges is managing dependencies between tasks, as some tasks may need to be completed before others can start. Another challenge is resource contention, where multiple tasks compete for the same resources, leading to potential conflicts and delays. Additionally, monitoring and debugging concurrent pipelines can be more complex, requiring advanced tools and techniques to ensure smooth operation. There are several strategies for optimizing pipeline concurrency. One effective approach is to identify and parallelize independent tasks, allowing them to run simultaneously. Another strategy is to use resource pools to manage and allocate resources efficiently. Implementing caching mechanisms can also help reduce redundant work and speed up the pipeline. Additionally, using pipeline templates and modularizing tasks can simplify the management of concurrent pipelines. Finally, leveraging cloud-based infrastructure can provide the scalability needed to handle high levels of concurrency. Parallelizing independent tasks is a key strategy for optimizing pipeline concurrency. By identifying tasks that do not depend on each other, you can run them simultaneously, significantly reducing the overall pipeline execution time. For example, in a build pipeline, you can parallelize tasks such as code compilation, unit testing, and static code analysis. Tools like Azure Pipelines allow you to define parallel jobs and stages, making it easier to implement this strategy. Properly parallelizing tasks requires a thorough understanding of task dependencies and resource requirements. Resource pools are a valuable tool for managing pipeline concurrency. By grouping resources into pools, you can allocate them dynamically based on the needs of concurrent tasks. This approach helps prevent resource contention and ensures that tasks have the necessary resources to execute efficiently. In Azure Pipelines, you can define resource pools for agents, storage, and other resources, allowing you to manage concurrency at a granular level. Effective use of resource pools requires careful planning and monitoring to ensure optimal resource utilization. Caching mechanisms can significantly enhance pipeline concurrency by reducing redundant work and speeding up task execution. For example, caching dependencies, build artifacts, and test results can prevent the need to refetch or recompute these items for each pipeline run. Azure Pipelines offers built-in caching capabilities that allow you to cache files and directories between pipeline runs. Implementing caching requires identifying the items that can be cached and configuring the pipeline to use the cache effectively. Proper caching can lead to substantial performance improvements and cost savings. Pipeline templates are a powerful way to manage and optimize concurrency in complex pipelines. By modularizing tasks and defining reusable templates, you can simplify the configuration and maintenance of concurrent pipelines. Azure Pipelines supports YAML templates, allowing you to define common tasks and stages once and reuse them across multiple pipelines. This approach not only reduces duplication, but also ensures consistency and best practices across your pipelines. Leveraging templates requires a good understanding of your pipeline structure and the ability to abstract common tasks effectively. Cloud-based infrastructure provides the scalability needed to handle high levels of pipeline concurrency. By leveraging cloud resources, you can dynamically scale your pipeline execution environment based on demand. Azure DevOps, for example, offers scalable build and release agents that can be provisioned on demand. This approach ensures that your pipelines can handle peak loads without requiring a large upfront investment in infrastructure. Using cloud infrastructure also provides flexibility, as you can easily adjust resource allocation based on changing requirements. Effective use of cloud resources requires careful cost management and monitoring. Monitoring and debugging concurrent pipelines can be more complex than sequential pipelines due to the parallel execution of tasks. Effective monitoring requires comprehensive logging and visualization tools that can provide insights into the performance and status of concurrent tasks. Azure Pipelines offers built-in monitoring and reporting features that help track pipeline execution and identify issues. Debugging concurrent pipelines may involve analyzing logs, tracing task dependencies, and using advanced debugging tools. Ensuring robust monitoring and debugging capabilities is essential for maintaining the reliability and performance of concurrent pipelines. Let's consider a case study of a software development team that successfully optimized their pipeline concurrency. The team was facing long build times and resource contention issues. By parallelizing independent tasks, implementing resource pools, and leveraging caching mechanisms, they were able to reduce their build times by 50%. Additionally, they used pipeline templates to standardize their pipeline configurations and adopted cloud-based infrastructure to handle peak loads. As a result, they achieved faster delivery cycles, improved resource utilization, and significant cost savings. This case study highlights the practical benefits of optimizing pipeline concurrency. To optimize pipeline concurrency effectively, consider the following best practices. 1. Identify and parallelize independent tasks to reduce execution time. 2. Use resource pools to manage and allocate resources efficiently. 3. Implement caching mechanisms to avoid redundant work. 4. Leverage pipeline templates to standardize and modularize tasks. 5. Utilize cloud-based infrastructure for scalability and flexibility. 6. Ensure comprehensive monitoring and debugging capabilities to maintain reliability. By following these best practices, you can achieve significant improvements in pipeline performance and cost efficiency. Optimizing pipeline concurrency is a crucial aspect of DevOps that can lead to faster build and release cycles, better resource utilization, and cost savings. By understanding the principles of concurrency and implementing strategies such as parallelizing tasks, using resource pools, and leveraging cloud infrastructure, you can enhance the efficiency and performance of your pipelines. As a next step, assess your current pipeline configuration and identify areas for improvement. Implement the strategies discussed in this presentation and monitor the results to ensure continuous optimization. With the right approach, you can achieve a highly performant and cost-effective DevOps pipeline.